wait a second for our broadcast to start up, and it looks like we're live broadcasting. So, and I should get my presentation open. That would be helpful. So tonight I want to talk to you guys about continuous deployment, which is something I've worked on at the Social Station, building out a continuous deployment flow over the past few months. I've learned a lot about it. I found it's worked really well, so I'm excited to kind of share that with you tonight. So for those of you who don't know me, I am a certified Force.com developer and Salesforce administrator. I've been working, on the Salesforce platform on and off for a few years, but my real background is kind of in full stack web development. So I've done, Java development, PHP, JavaScript. And for those of you who want to connect with me online, that's my website and Twitter handle. You can reach out to me after the meetup. And I am the CTO of a company called The Social Station, which is a social media marketing startup right here in Allentown. We're actually just a block away over at the Velocity Center. And what we do as a company is we handle Facebook, Twitter, all the different type of social websites on behalf of the business, like restaurants, hotels. So we deal with small businesses, local businesses that don't really have the staff themselves to dedicate to online marketing. And the interesting thing about where I work at the Social Station is we focus our company as a technology company. So we have a lot of different applications and services we provide. We have mobile apps, we have client-facing apps, and internal apps. So I have a lot of applications that I kind of oversee and make sure are always available. So continuous deployment is something that's I've really kind of narrowed in on and focused on because a startup is an ever-evolving business. There's changes you need to make all the time. So you need to make sure you can make changes and keep all of your services online and functioning. So I'm going to kind of talk to you a little bit about that and how I found this workflow really kind of fits in with the model of what I've been doing at the Social Station. So the big thing to kind of start off with is, first of all, what is continuous deployment? If you look online, there's a ton of different definitions out there. And I kind of look at it as two different ways. You have the core of what continuous deployment is, which at its basic level is just automatically deploying out your code based on some parameters that you've set regularly. So when features are done, when you're done developing things, you are getting it out to your customers or users immediately. There's no lag time. But really, to achieve continuous deployment, it's a layer of best practices that you need to follow. And you can't just jump to that automatic deploying phase. You need to make sure you have your whole development process and workflow functioning correctly and thought out as best as possible before you can jump to that final phase. So tonight, as I kind of go through everything, I want to cover each of the core steps that you need to consider before you can jump to that automatic deployment and deploying continuously. So I'm going to cover the version control, the actual continuous integrations of running unit tests, feature acceptance criteria, which is merging in your features into your release branch ready for delivery, continuous delivery, and how that actually differs from continuous deployment. And then the real key, which I'm going to spend some time on, is zero downtime deployments, which is the key to making a continuous deployment workflow successful. So why would you want to use a continuous deployment strategy? Well, one of the main reasons is you can be a lot more adaptive to business needs. There's been different developer practices that we've kind of been refining over the years. There's been waterfall to start with, where you build a whole application kind of from end to end, thinking it out, and you don't deliver that until everything is done and you've kind of met all of the business needs. That's been kind of proven to be a slow process, not always the best practice. So there's been refinements to that. There's agile methodology has become really popular, where you develop things in 3 to 4 week chunks of time and you're releasing regularly, getting your features out to your users as soon as possible. But my opinion is that's not even fast enough. In this day and age, really business needs change on a daily basis, no matter where you're at, whether you're at a startup or you're at an established company. As developers, you need to be more reactive and adaptive to how a business functions. So continuous deployment is really key with that because it decouples your deployments and your releases from any cycle. It's based on features. So as you're working on a feature, if a feature takes 2 days to get done, well, you can deploy it immediately once you're done with that. Or if you're working on a feature that takes 3 months to get done, that feature is released when it's ready and it's not tied to any set release schedule. So you don't have these kind of awkward things like you have in Agile where you have 3-week sprints and you have a task that's maybe 3.5 weeks and you accomplish it over a sprint and then it's kind of just sitting there holding up another three weeks until it's released. So continuous deployment can really help with kind of meeting business needs and being more reactive to feature releases. The other thing continuous deployment is great for is it embraces automation. If you don't have a set kind of strategy of deploying on a regular basis, it's really easy to kind of fall back on, just manually running deployments, having some developer or yourself kind of watching over the steps, one at a time. And that's, time consuming, error prone. So to really succeed and deploy automatically, everything has to be automated so that it's reproducible, it's, less error prone, and it's less time for, developers or admins or system administrators to have to worry about the deployments. It's something that just happens on a regular basis. So by adapting continuous deployment, you really embrace more automation and have developers focus on what actually matters, which is developing and improving your application more. So really, what is continuous deployment best for? It's a great workflow for any type of application where you have full control over the entire experience. So it's running on servers that you can control, either like Heroku, where it's an end-to-end solution where you're writing your code and you're deploying it out to Heroku, which is a service that you have access to. So it works great for anything that you're delivering to your own business users, or it's a service you're providing to your clients or customers. It's not a great workflow when you're dealing with self-install applications. So if you're doing something like you're making an app for the App Exchange, or you're releasing things to an app store like the iOS App Store or Android Marketplace, that's not great because you don't have full control over that last step of the installation of your software. But when I kind of look at this, because I view continuous deployment as a set of best practices and strategies for developing, it's better to implement some parts of continuous deployment if you can't implement all of them. So implement what you can. That's why I kind of broke it out into different sections as we go through here. So if you can't implement everything end to end, implement what you can, because it's more beneficial to kind of automate as much as you can in your workflow. So let's kind of get right into it. So the first best practice is really version control. And you want to, first of all, make sure you're using it. And I say that because it's really easy as Salesforce developers for us to kind of skip that step. Salesforce has a great, sandbox setup and tools to develop that, if you're just doing a quick project, it's tempting to just, create a sandbox and start developing right on Salesforce. But if you really want to hone in on, your deployments and make sure that, more than one developer can work on a project at a time, you need to use some kind of version control. Git's been my, choice to go with. There's other ones out there, but the key is just got to version what you're doing. And it goes beyond that too. You need to have a workflow that all of your developers on the project agree to, because you need to make sure that there's, not someone doing something rogue out there, breaking the workflow, or, when you're deploying on a regular basis, you need to make sure that there's a set process being followed and things don't, jump in line. So you need a great workflow. My favorite workflow for kind of dealing with continuous deployment is GitHub flow. I'm just going to kind of link off to here and show you how the workflow kind of works. It's really nice, and it's geared towards deploying on a regular basis because it's just one branch per feature. So for those of you who are maybe not familiar with how a version control system works, you have kind of a main line of code, which is your active set of code that's going to be in a production your users are actually going to be using. And then you can create kind of copies of that called branches for work that is in progress. So the way GitHub flow works is for each and every feature, you create a branch. You then add your commits, which is just changing the pieces of code. And when you're ready and you feel like that feature is set to be reviewed by others, you create a pull request, which for those of you not familiar with GitHub terminology, a pull request is just kind of like a formal request for a code review. It's asking another developer or someone else with the knowledge to look at the code that you just wrote and verify it does what you say it does, and it kind of meets the established standards and practices that you have with your application. So once you open a pull request and you start that process of reviewing your feature, you're going to have some discussion off of it. And this is completely normal. It's, a code review should not just automatically be accepted, because you're losing the benefit from that process. It's a back and forth. So you discuss the code, you work on improving it, and you make some more commits, you make some more changes. And once you finally have reached that final endpoint where you agree it's, this feature is what we want, that's when you merge it in. And it moves back into your main line of code, ready for deployment. So, the GitHub flow is really, just one branch for each feature. Other workflows are out there. So if you have a different workflow, just like the traditional Git flow workflow, where you have kind of multiple layers, that's fine too. The key is to just really find a workflow that you like and stick to it. The next layer of best practices is continuous integration. And again, as Salesforce developers, this is something that for the most part we're familiar with. Continuous integration is really about writing unit tests and testing and verifying your code does what it says it does. And this is extremely important when you are releasing on a regular basis, because you need to make sure anytime you change your code that everything else in your application is still working. So, Salesforce has kind of minimum coverage requirements, but you need to think beyond just coverage. You need to think about actually exercising the functionality of your application when you're testing things. So when you're not developing for Salesforce and you're doing something like Heroku, you want to make sure that you're testing your database layer, you're doing security tests, any integrations. Anything that you can automate for testing is going to help you out down the road, because it's going to avoid a broken build or a deployment that has some kind of adverse effects. And if you're writing lots and lots of unit tests, you're going to need to offload it to a CI server solution. Now in Salesforce, unit tests have to be run in a sandbox, so you don't have many options there. But if you're developing for Heroku, there are tons and tons of options out there of CI solutions that integrate really nicely right into your Heroku workflow. And one of my favorite ones is Travis CI. And if you're using some kind of service like GitHub to actually host your code, Travis CI can integrate with both Heroku and GitHub, so that this is a view right here on GitHub of a feature that had its unit test fail. And you'll see right here on the option to merge that feature in, it's letting you know that the build failed. So it's integrated nicely. And you want to find a solution that is testing not only your main line of code, but is intelligent enough that when you make your branches and you start other features, that it's picking up those branches and testing your branches independently so that you're aware ahead of time that you're not going to merge in something that's broken. Nice thing about Travis CI is it also does it will merge on every commit master behind the scenes and actually run your unit test suite against your merge results. So if you had something where you branched your code, someone branched after you and merged back into master before you finished your feature, and somehow that caused a situation where you're gonna have a broken unit test or some kind of broken test, Travis CI is checking those results as well. So that's kind of a solution I recommend, but there's a ton of different CI solutions. And you want to look for something that's simple and you can script. This is kind of a configuration for demo I'm going to show you a little bit later. This is everything you need. It's a Ruby application to run the unit tests and deploy to Heroku. So it's drop dead simple for configuration. So once you have your test down and a workflow for dealing with your code, you have to really think about your feature acceptance criteria. And really, this is just that last step I was talking about of merging your branches into your master branch of code. That when you are releasing on a regular basis, you have to think that the second you're merging that code in, it is production ready, and you could have users taking advantage of that feature. So as much as it's not, much as we'd like to say it's easy and you can, every single feature is going to be releasable without any downtime. There will be some features developed that do require downtime, such as if you're doing any like major migrations, you're moving between data stores or major refactors. There's going to be some type of downtime on those deploys later down the line. So you want to really think about in your code review process, making sure that you catch those and you're really thinking that when I merge this in, it's going to be used by users immediately. So pay attention to that on the feature acceptance side. So if you've gotten to this point, you've essentially reached the continuous delivery phase. And continuous delivery is just slightly different from continuous deployment in the fact of continuous delivery basically follows all the practices of continuous deployment, except you're not automatically deploying. You're getting your code into a single release branch that at any time can be released to your end users, but it's not automatically being released. And this could be the stopping point for a lot of workflows. So as I mentioned, if you're doing something with the App Exchange or you're doing a mobile app, this is where you kind of have to stop because you don't have control over that end installation process. But what you do have control over is making sure that you can release an update to your App Exchange app at any time or release something to the App Store at any time. So, you want to make sure that your process up to this point is refined so that you can release at any time. So that's really what continuous delivery is. And even if you kind of stop here and you decide you don't want to make that deployment step automatic, that's the next step, which I'm going to get into, is kind of zero downtime deployment, is still something you want to consider because deployments should be as much automated as everything else in your workflow. So now we're getting into the crux of continuous deployment. And to make continuous deployment successful, you need to make sure that when you deploy your code, you're not affecting your end users at all. So the idea is, when you're doing continuous deployment, you might be deploying, 10, 15 times a day. That's in the middle of the day, when your users are actually using your application. And, nowadays with kind of 24/7 business and, international use, it's tough to really schedule downtime to actually do deployments. So zero downtime is really key in making sure that you can release at any time and have zero impact to your end users. So that means that your end users can be on the website actively using it, and a release happens and they were not affected at all. They didn't know anything happened. So that's really the key here. I'm going to kind of explain how that works. The nice thing is if you're using Salesforce or Heroku, this is really handled for you. There's a little, thing you have to do to enable it in Heroku, which I'll explain when I'm done kind of going over the background of how zero downtime deployment works. But, Salesforce has handled this all for you. So what I'm going to go over here is just kind of to give you the background knowledge and understand how a zero downtime deployment works from a conceptual standpoint. And this is something I've worked on implementing over the past few months at the social station. So I've done a complete manual zero downtime deployment strategy for what we have, because we're hosted in Amazon and we're not using something like Heroku. So I'm pretty familiar now with the process. So what is the key to a zero downtime deployment? The key is what is called GreenBlue deployments. So a GreenBlue deployment is going to require a few things. It's going to require a load balancer, which is really just a piece of software that's kind of routing your traffic from your users to a particular server. You're going to need a load balancer, and then you're going to need two environments. You're going to need your green environment, which is your existing production code, which is out there actively being used by your users, and then your blue environment, which is your new environment that you're going to be having your new code release run on. And this blue environment has a couple of different options. It can be an existing environment. So you could have two different environments configured ahead of time, and you're kind of on your deployment switching back and forth between those environments. Or it can be an on-demand environment, which is what I actually went with the social station. So what is an on-demand environment? An on-demand environment basically means each and every deployment, your environment is created from scratch. And this kind of continues with the automation, where the steps to get your servers up and running are scripted out and they're reproducible, so that every time you do a deployment, you get a brand new, fresh environment. And there's some real benefits to that, because you can do things like install security updates and other things along the way when you do an on-demand deployment, so that every time you run a deployment, you have a fresh, up-to-date environment, and you don't have to do any maintenance windows to kind of keep your environments up to date. But really, existing or on-demand, either model will work. You just need a separate environment. Once you have those environments, the next step, and it's lagging here a bit, the next step is you do a deployment to your blue environment. So this is where you put your new code on the blue environment. And the key here is when you get that code running on the server, you run a set of automated tests. And these tests are different than the tests that you're running than your CI tests, your unit tests. These are tests that exercise and make sure that your environment is actually working. So at its basic level, you might just be doing, a ping on some, endpoint or something like that, just to make sure you get a response. At a more complex level, you might be, logging in as a user, running a couple of different pages, doing some kind of load tests. This can be as complex as you want it to be, but you want to make sure whatever you're doing here, that you feel confident with the level of tests that when you're done running those test suites and the result you get back, that your environment is working. And if the environment doesn't work, there's some kind of problem with your deployment, you put some bad code out there, maybe you're doing an on-demand blue environment and one of the security updates has a conflict with your code. Right now, in this stage of the deployment, if it fails, your users have no clue anything went wrong at all. Your blue environment is completely off on its own. The load balancer is not pointing any traffic to it. So let's say you merged in a commit and right before lunch, you went out to lunch, you're enjoying your lunch, and you get an email that your deployment failed. Well, you don't have to rush back to the office and fix your code or anything like that. You can keep on enjoying your lunch and come back later and deal with it, because your users are not affected at all. It's off on its own blue environment and they're still using the green environment. So let's think positive. Your blue environment's actually working. The next step is you're going to move some of your traffic to the blue environment. And I say some and not all, because there's a different type of failure that can occur during this. So, you're right in, step 2, you have all your automated tests and you feel like the environment's working. Well, there's still some things that kind of crop up, maybe performance issues. You didn't, have proper load tests, or there's just something that you never thought to write a test for. So what you want to do during this stage is only move part of your users over and monitor your error rate. So if you're starting to get a ton of errors, this is another abort phase. This is where, maybe you move 5 or 10% of your users over, you're starting to see a high error rate. You can stop the deployment, shift everyone back over to green, and again, kind of deal with the issue on your own time. Again, thinking positive, you moved over a percentage of your users. You want to kind of scale it. So you start with 5 or 10%, and then you kind of slowly ramp up until 100% of your users are on your new environment. And that rate can be as much as you feel comfortable with. So, some services out there, some companies will move everything over in a period of 5 or 10 minutes. Others, like Facebook, their deployments actually can take up to a week, where they're dealing with so many different servers that they'll roll out to 5 or 10% of their servers, and over the course of a week slowly update everything. So it's a massive rolling update. So they might be a week in until every single user along the way has an updated experience of the new code. So when the screen comes back in a second, I'll show you the next step, which is all traffic to the blue environment. So you've kind of gone through the scaling, the rolling, update, slowly moving your users over. This is kind of the final phase, where now all of your users are on your new environment with your new code. The load balancer has stopped pointing at the green environment. And technically this is where the names switch, because the blue environment is now running the latest version of your application. All users are using it. The blue environment has now become the green environment, and vice versa. And if you're doing an on-demand type of deployment, what you do now is you shut down the green environment, destroy it. It's not going to be used again. And the next time you run deployment, a brand new environment will be created from scratch. This is also another abort phase. So if you move all of your traffic over and you're still having problems, something came up they didn't catch beforehand, well, what you can do is actually just run a deployment again, but with the old version of your code. Or if you're doing an existing environment, your green environments, which is now the blue environment, still kind of sitting there, you can reconfigure the load balancer to point back to the old version of your code. But either way, it's this type of setup allows you to roll back to a previous version of your application if something does go wrong. So that's really how GreenBlue deployments work, and this is really the key to making sure that there's no downtime for your users. But there's a lot more to that, and this is where you want to pay attention to as developers. So from an infrastructure standpoint and kind of a deployment strategy, that's how that worked with GreenBlue. But when you're developing code, you need to think about the effects of what just happened. So you have sessions out there, and this is something, fortunately, you don't really have to deal with on Heroku, because Heroku doesn't store sessions on the dynos themselves. You're storing sessions in some kind of external data store. But if you were doing something like a Tomcat that had, which is Java, and had your sessions stored on your servers, you just change the servers on your users. If their session was on that server and you switch into a new server, they're going to get logged out. So you need to make sure that you have your sessions in some kind of external data store or being replicated between your environments, or your users are going to get logged out. But the other thing you really have to consider about is during a GreenBlue deployment, you have a situation of simultaneous environments where your old set of code and your new set of code are running side by side. So that causes some complexity for things like database changes, message queues and whatnot. Basically, you can't do any type of migration that is going to break the previous version of your code. Now, working with Salesforce, we should all be kind of familiar with that. That's how it just kind of works on the Salesforce platform with fields, where you can't really easily rename things and delete things without breaking a whole bunch of things. So we're kind of used to developing forward-thinking changes. So if you're kind of just doing Heroku development and you're working with databases for the first time, you have to kind of adapt that same mentality where you can't just remove fields, you can't rename them. You have to only add new fields and have forward-thinking migrations. Now you could go back and maybe a deployment a few stages down the road, do some destructive changes, but you can't simultaneously have two environments running at a time that will have some kind of migration that will break things. The same thing happens with message queues, and this is something to pay attention to with Heroku, because you have the worker and web dyno concept, and the most likely way to talk between the two is you're going to set up some kind of message queue. So if in your code you changed anything with the messaging of those messages, you might have an old version of your code consume a new version of the message and doesn't know how to understand it. Or vice versa, you wrote your new version of your code to not understand the old version of your message. Well, you're going to run into this in a blue-green deployment where you're going to have old versions of your application consume a message that it doesn't understand. So the way to handle that, and it's just kind of a real basic kind of first layer of things, is you do some type of versioning on your messages. You put some metadata on it to say, this version of the application understands this type of message. Now, that has its own set of problems, because if you're not, if your messages are not fault tolerant, you can have messages that never get consumed and kind of left because you might have had the old version of code disappear and it was never processed. So you have to really kind of think about any changes that you make that you're not going to break anything during your deployment process. The other thing is your front-end application. And in kind of modern web development, everyone's kind of moving towards the trend of single-page applications where you loaded up one page and all your JavaScript and your full application is hitting back-end API. Well, when you're changing out the server, you're changing out the API version, that's decoupling your version of your front-end application with your back-end server. So you might have one of your users opening up your application in a browser tab in the morning, and they keep that tab open all day, or I know sometimes I have tabs open for days on end. So you have to make sure that, like anything, you do forward-thinking changes, that if an old version of your front-end application is hitting a newer version of your API, that none of the changes in there are going to break anything. Now, there are some patterns for dealing with that type of situation where you can do some type of alerting to the end user on the front end interface where you're checking a version and you say, hey, a new version of the application has been released. You need to reload the page. I've actually seen that used. I don't know how many people here do fantasy football, but I noticed the ESPN fantasy football app this past year has adopted a continuous deployment strategy where I've seen them release code changes in the middle of Sunday football, and you'll get a notice at the top of the app saying you need to refresh the page to get the latest changes of the application. So that's kind of a method that they've adapted so that they can change out the front-end HTML and JavaScript code for bugs and stuff. So that might be a model that you go with. But it's something you just have to consider about as a developer and how it's going to affect your end users when you're striving to have zero downtime. So how do you actually do a zero downtime deploy in Heroku? Well, Heroku makes it really simple. There is a feature called Preboot, and this has been in testing for a while, but it's now generally available as of October 2014. And this does exactly what I just described. It does a blue-green deployment in Heroku. And all you need to do to enable it is in your Heroku console, you type Heroku features enable Preboot, and it turns on the feature. Now, it does have some requirements. You need at least 2 web dynos. And I couldn't find any documentation exactly out there from Heroku on why that requirement is, because they're not doing an existing environment thing. It's not updating one dyno and then updating the other dyno. It actually creates another set of dynos when you do your deployment. But from what I can tell in my own testing, I believe if you only have one web dyno, Heroku doesn't actually give you a load balancer. So a load balancer is important to doing a GreenBlue deployment, because you need some type of piece of software to actually direct where your traffic is going. So when you add two web dynos, that's when you seem to get a load balancer, and that's what enables Heroku to alternate which environment your code is running on. The other thing to be aware of is this only applies to your web dyno layer. Worker dynos kind of follow the same pattern that they always have, where when you do a deployment, it just spins up a new environment and kills the old dyno. So you have to be aware of that you're not going to have zero downtime on your workers, but that shouldn't have any effect on things because it's just background processing anyway, right? But it does add some extra complexity, as I said, to deployments, because now you might have a new version of your worker dynos and an old version of your web dynos out there. So again, pay attention to your messaging between the dynos to make sure everything works fine in that window. The other thing to be aware of with Preboot is it's not super intelligent. So the way it works is it just spins up a new environment, waits 5 minutes, and then cuts over to the environment. So if your deployment, for whatever reason, takes longer than 5 minutes, it's going to cut over and your application is going to be down. Now, before Preboot, hopefully you've noticed this if you've been developing a Heroku application, that your application is taking forever to start up. So hopefully no one's running any applications that take longer than 5 minutes. But it's not going to wait for your application to actually be up and running. It's just waiting a set time limit of 5 minutes. So on the Salesforce side, continuous deployment's kind of interesting. So you may have noticed a few things that I've mentioned along the way that if you really know the Salesforce platform, is going to cause some problems. So the big one is on the continuous integration side of actually doing feature branches and versioning out your code. Right now, to run unit tests in Salesforce, you need a sandbox. And sandbox creation is a manual process. You have to log in to your organization and create a sandbox. To really make continuous integration successful, that part needs to be automated so that you could create a sandbox on demand and run your unit tests against the sandbox dedicated just to that version of your code. So that's not something that's in Salesforce yet. So if it's something that sounds interesting to you, you want to really adapt feature branches and be able to kind of independently test your features, I recommend kind of reaching out to Salesforce, becoming active on some of the Salesforce boards, and kind of letting Salesforce know that this is something you want, because I have to imagine it wouldn't take too much for Salesforce to build out some type of API or something that you could script out to create a sandbox. That would be really nice and make continuous deployment a lot easier. But with that said, there are some things that I want to kind of point out in Salesforce that might make your deployment process a little bit easier. So the big one is quick deployment, which is a new feature in pilot as of winter 15. And for those of you not familiar with the deployment process now in Salesforce, the way it works is when you run your deployment, it runs your unit tests against your production org, and then it deploys out your code. Well, what quick deployment does is it decouples that. So it lets you run your unit tests in advance and get that pass-fail result before you do your deployment. And then you have a window after your unit tests pass that up to 72 hours later, you can run your deployment, which is nice because with deployments in Salesforce, they get kind of queued up. You might have some kind of manual changes that you have to run after your deployment. So if you have a big unit test suite, you're not kind of sitting there waiting for the queue to run through all your unit tests and then do the deployment. It should be hopefully a smaller window that you're waiting for your deployment to succeed. So if that's something that interests you, you have a lot of unit tests that are running, definitely look into taking advantage of quick deployment. That will ease the pain on some of your deployments. So what I want to do now is I've actually set up a little demo application, and I want to walk you through the actual kind of end-to-end steps in real time of how a zero downtime deployment works on Heroku. So we'll have to see how well this works and how interesting it is, because we might be waiting up for the server at some points. So what I basically have here is Heroku has in their kind of demo suite, they had a sample application that uses Ruby and WebSockets to make a chat client. Well, I took that project on GitHub and I forked it, which is I just basically made a copy of it to make changes. And I changed up the application a little bit. So I made the backend Heroku component report the current date, time, and the version that it's running. And then the front end part of it just is a visual display so you can see what's happening on the backend server. So every, I believe it's 15 seconds, you get kind of a ping with what the new version is. So what I'm actually going to do now is I'm going to deploy out a new version. I'm going to deploy version 2 without reloading the browser tab or anything. And behind the scenes, the new version of the application is going to be released. So I start here in GitHub, where I already have a branch, a feature branch, where I've made my change. If we look at the actual commit here, this was just a simple bump of the version number to version 2. I've already had my unit tests run. Travis CI has run against the set of tests, and it passes the build. So it's been passed, the tests have been run. It skipped the deployment at the time because it was in a branch. So now I'm ready to release this. I'm going to hit merge pull request, confirm the merge. And now this change is in the master branch of code. And what should be happening now is in a minute or so here, we will see pop up a continuous integration job in Travis that it will actually deploy out to Heroku. So I'm using the free tier of Travis CI right now, so there's no dedicated job queues or anything like that. So I'm just kind of waiting. I'll have to wait a minute or so to see if it pops up. So while we wait, now might be a good time for any questions that anyone has.
Run out of questions.
Sure.
So going back to blue-green.
Yeah.
When you reach a failure state in the second point where you move some users over, what are the approaches to handling the new functionality that they may have used, the new data they may have created by those features when you end up having to roll them back to the old version?
Yes, that is a really complex thing to worry about. So really, and something I didn't mention as part of the process for kind of developing things, a common thing that you do when you're doing continuous deployments is you use feature flags. So you develop features and you don't actually enable them for your users until you've tested them with a subset of users in your production system. So you do your deployment, your new functionality isn't enabled yet, the code ends up out there, and after you've tested it with a subset of users, what you could manually deal with, maybe it's just your developers or things like that, that's kind of a key way of handling it.
Are there performance issues with that? Time goes on, like everything's going to be controlled by flags. You're going to have to check.
There's cleanups that you have to do and things like that, but it depends on how complex you architect the system. You maybe have some generic feature flag system, and occasionally you clean up your feature flag table or something like that.
Okay.
So continuing on with this, deployment here, what happened here is Travis CI picked it up. It ran the unit test suite on the master branch. It passed it. It's preparing for the deployment here. And then, Heroku uses Git as well. So it pushes up to Heroku's Git repo. And now it is triggering everything in Heroku. So if I switch over to my logs here in Heroku, you'll see here what actually has happened. So this is from earlier. Actually, it's up here earlier where I started my server before. It's actually created a set of 2 new web dynos, and it's up and running. But if we look over here at the actual application, we're still using version 1. So right now we're in this window where Heroku is, that 5-minute window where it's waiting to do the switch over. So I'm going to leave the logs open here, and in a couple of minutes, what you'll see is a log from Heroku saying it's switching over to the new servers. So are there any other questions?
With the worker dynos, when it does the switch over, so it does not update the worker dynos. So how
right.
does it just make a copy, or they just get whatever version of the code?
So the worker dynos follow the previous, the standard Heroku deployment, where it kills the old dyno and just starts up a new one.
On the new version.
Yeah, on the new version.
Ryan, you were talking about sandboxes
Mhm.
from Salesforce. Have you looked at Environment Hub at all? It may be something related to a partner environment.
Okay. No, I've not looked at
What
Environment
Environment
Hub.
Hub lets me do is right within Salesforce, I can request a sandbox basically with 1 or 2 clicks. So what I was thinking is, I don't know if they expose an API from Environment Hub, but that would be one
Yeah, that could be very helpful.
APIs for creating sandboxes.
There is a way to create works programmatically. I don't know how we're doing it, but Financial Force has a way to, we're doing that for our scenario where it spins up a whole new org. It spins up trial orgs which live for 24 hours, so it'll run your tests and then they just ignore it, and then the org
Is it using a trial template?
Yeah.
That's tied into Environment Hub now, where once you create your template, you can create trial, you can create new orgs based off of your template inside of Environment Hub. Okay. And it's probably because of your partner. I think, I don't swear to the wrong this, but maybe we have it. I have heard rumblings of a Apex compiler eventually coming out. So that would kind of negate some of this environment, but you can actually run the unit tests outside of the sandbox.
Yeah. Yeah, and from what I've seen from Salesforce, they seem to be really interested on kind of making the developer workflow a lot easier. So they're kind of focused in on that stuff. That's why I'm saying, if this is something that interests you, get it out there and say that, this is a priority for them to work on, because they're definitely working on like the metadata API, and they're trying to get more things that you can get into version control. So we probably have about another 60 seconds or so until we'll see the logs where Heroku does the cut over to the new servers.
Ron, I got a question.
Sure.
So if you have this whole, continuous deployment thing set up, how would you integrate a QA person to someone else who's going to go and test the code other than a developer code checking it to test that feature before we get out? How would you see that process work?
Yeah, so there's a couple of different ways to do it. One way is you do continuous deployment to your staging environment. So, maybe you're not going right to production, your continuous deployments to your staging, and you still have to get things approved in a staging environment. So in that way, you've just kind of automated your regular deployments to staging, and then QA always has the latest version of the code to test. The other way is what I was mentioning before, where you use kind of feature flags. So you do your code changes, you deploy it out to your production all the time, but you don't enable any of the new features until a QA has actually tested it. And the testing can actually occur right in production then. You maybe have some QA resources built in your application that are only available to QA users in production. And the feature, you turn on the feature flag just for your QA users. They exercise the functionality, and then once it passes there, you enable the feature flag for more users. So what we've just had happen here now in the deployment, you'll see the previous version of the dynos was shut down. And right here, the connection was closed from the web application, and the new one was opened on the new dyno. And if I switch over here, it shows we're on version 2, and I never reloaded the tab. The browser kept the connection open the whole time through. Heroku, through the power of a load balancer, didn't even know anything changed behind the scenes. So that's really the magic of kind of a zero downtime deployment. It's really nice when it actually works. So. Any other questions?
Just kind of building on what Rob was saying. So does GitHub Flow have anything as part of their pull request where you might want to loop in? Typically, you do like your code reviews and stuff as part of your pull request.
Right.
Would you suggest looping in QA on a feature by feature basis, or waiting and then only learning about it once it's merged into like your development stream?
Yeah. Really, part of the idea behind GitHub Flow is it even empowers non-developers to, make that final sign off on releases. So that could be a process that you have adopted. And I've done some reading online of some other companies that have done that, where actually, that goes through a code review of a developer, but then QA will look at it. They'll look at the code themselves, look at understanding what is changing. And QA is actually the person clicking merge. And what's nice when you do that, really, and I forgot to mention this, during the presentation, but the person who's merging a feature into your main branch should not really be the developer who developed the feature. You want it to be someone else, because it spreads the responsibility. It makes sure that the person merging in feels confident enough with that feature that they're giving it that second stamp of approval. Because they're now going to be on the hook if the deployment runs and something goes wrong. So it is common in some workflows to have that person who's doing the merge be a non-developer. I've also seen too companies who don't do the full continuous deployment. Maybe they're only doing continuous delivery. I have seen some companies, what they'll do is they'll have the code get all set in the master branch, but then anyone can deploy. So QA can deploy. So I've seen like chat rooms set up where on every feature that's merged into the master branch, like a little the change set is published to the channel. And then someone from QA can see that, change set. It's like, oh, I want to test this. This needs to be out in production. And, if the right scripting and stuff, they can type in the chat room, deploy prod or something like that, and then do that manual kickoff of, deployments. So that's, another process that, can work out. Any other questions? All right. Well, that's the end of the presentation. Thank you for your time.